The overall heat transfer coefficient. A heat exchanger typically involves two flowing fluids separated by a solid wall. Heat is transferred. Look at this picture. Cold fluid, hot fluid. From the hot fluid to the wall, convection occurs. Through the wall, conduction occurs, and from the wall to the cold fluid, convection occurs. So the thermal resistance network is two convection and one conduction resistances. This one, wall, hot fluid, here convection, through the wall, conduction, and from the wall to cold fluid, convection. So two convection, one conduction. Resistance for convection from hot fluid to the wall, Ri, our input is that means 1 by HIAI. Through the wall, conduction, R wall, and from the wall to the cold fluid, R naught, our output means 1 by H naught A naught. For a double pipe heat exchanger, the thermal resistance of the tube wall is R wall is equal to ln d naught by di, that means outer diameter divided by inner diameter divided by 2 pi kl. Equation 1. The total thermal resistance R total is the equivalent of all this, R input plus R wall plus R output. So R input means 1 by HIAI, R wall means this one, ln d naught by di divided by 2 pi kl, and RO or R output means 1 by H naught A naught. This one is equation 2. When one fluid flows inside a circular tube and the other outside of it, we have AI is equal to pi DIL and AO is equal to pi DOL. There is a clear picture. Heat transfer from this. This one is outer fluid, there is inner fluid. This is outer tube, this is inner tube, and there is the surface area. A outer means pi D naught DOL and A inner means pi DIL. It is convenient to combine all the thermal resistances in the path of heat flow from the hot fluid to the cold one into a single resistance R. We can write Q dot is equal to del T divided by R, that means UA del T, that means UI AI del T, or we can write UO AO del T. This is for inner and this is for outer. This one is equation 3. Here U is the overall heat transfer coefficient whose unit is watt per meter square degree Celsius, or you can write watt per meter square Kelvin. Cancelling del T, equation 3 reduces to 1 by UAS is equal to 1 by UYAI, or 1 by U naught UOAO is equal to R, that means 1 by HIAI plus R wall plus 1 by HOAO. This one, equation 4. When the wall thickness of the tube is small and the thermal conductivity of the tube material is high enough, that means R wall is equal to 0, and the inner and outer surfaces of the tube are almost identical, that means A inner is equal to A outer, that means A surface or AS. So equation 4 simplifies to 1 by U is equal to 1 by H inner plus 1 by H outer. This one is equation 5. There are two cases when H inner greater than H outer. We can write 1 by U is equal to 1 by H outer, and when H inner less than H outer, we can write 1 by U is equal to 1 by H inner. So these are the two cases of this equation 5.